Welcome to new session of the differential equation. In this session, we discuss also about exact differential equation. In the last session also we discussed about exact differential equation. We know the differential equation of the form m of xy dx plus n of xy dy is equal to 0 is exact differential equation if dou m divided by dou y is equal to dou n divided by dou x. If dou m divided by dou y is equal to dou n divided by dou x. So, we done some problems in the last session also. So, we know that it is m is a function of x and y and n is also a function of x and y. We are thinking it is that there is a solution u of x y such that m dx plus n dy is equal to du. So, have to find the general solution. See, we can move to one more question. See, we can move to one more question. In this question, number 2, we can write solve the differential equation. Solve the differential equation cos x minus x sin x, cos x minus x sin x, cos x minus x sin x plus y square dx plus y square dx plus y square dx plus 2xy dy plus 2xy dy is equal to 0. This is I would like to put, this is the equation number 1. Also find the particular solution, find the particular solution if it satisfies the initial condition, if it satisfies initial condition, if it satisfies initial condition, y is equal to 1 when x is equal to pi, y is equal to 1 when x is equal to pi. See, in this question we have to solve the equation number 1, that is the differential equation cos x minus x sin x y square plus x sin x plus y square dx is equal to plus 2xy dy is equal to 0. That is the differential equation. After getting the general solution, have to find a particular solution whenever x is equal y is equal to 1 when x is equal to pi and y is equal to 1. Okay. So, we can start the solution. Firstly, we can write m. Here m is equal to cos x minus x sin x, cos x minus x sin x plus y square. Therefore, dou m divided by dou y, we differentiate m with respect to y partially. So, cos x is a constant 0 and x sin x is again the terms contains only x, therefore, that is also equal to 0. So, we have we are differentiating y square is actually 2y. Okay. Similarly, we can write about the n is equal to 2xy. So, see, n is equal to 2xy, we can partially differentiate n with respect to x. So, have to find dou n divided by dou x. Therefore, this is equal to while differentiating this with respect to x, we will have the value is equal to 2y. So, here we have dou m by dou y is equal to 2y, also dou n by dou x is equal to 2y. Therefore, we can say that dou m divided by dou y is equal to dou n divided by dou x. Okay. Therefore, the equation 1 means the given differential equation is exact differential equation, is exact differential equation, exact differential equation. As we done before, we can solve either by integrating with respect to integral of m dx, u of x y is equal to integral of m dx plus g of y, or otherwise we can have integrate n dy plus some g of x, or g of x is the constant of integration and that is a function of x alone, because we are partial n contains the terms of x and y, and we consider that g of x as a constant of that integration, and after we find that g of x and we will replace g of x by new functions that we found from that. Okay, see here it is easy to work out with n. So, I would like to write this as u of x y. Therefore, I would like to write the solution. Therefore, the solution of 1 is u of x y is equal to integral of n of x y dy plus the constant of integration as a function in x, g of x. See, we all know the n of x y is actually 2 x y. So, this is equal to integral of 2 x y dy, 2 x y dy plus g of x is there. Okay. This is equal to integral of 2 x y dy, that is equal to 2 x y square by 2 plus g of x is there. Okay. So, we have this is equal to 2 x square y by 2, that is equal to x y square plus g of x is there. So, we found u of x y as the solution, u of x y as this is equal to x y square plus g of x, x y square plus g of x is there. See, nextly we have this is equal to we just partially differentiating u with respect to x y. So, dou u by dou y, okay, dou u by dou y is equal to that we done before, dou u by dou y is equal to, we all know it is equal to we all know dou u by dou y is equal to n. See, dou u by dou y is equal to n, and dou u by dou x is equal to m. Dou u by dou y is equal to n and dou u by dou x is equal to m. See, so we differentiate. You would like to differentiate. This is I would like to put it as equation number 2. We partially differentiate u with respect to x. So, dou u by dou x, we have dou u divided by dou x is equal to, here this is x y square, we partially differentiating x y square with respect to x. Therefore, that is equal to dou u by dou y is equal to, this is equal to x y square is y square plus again we have derivative of g of x. So, partially differentiating with respect to x, just differentiate, that is with respect to x, g dash of x, and this is equal to m, that is y square plus g dash of x is equal to, we have the value of m, the function m, we have the function m as this is cos x minus x sin x plus y square. So, cos x minus x y minus x sin x plus y square, cos x minus x y square, cos x minus x sin x plus y square. Okay, fine. So, we can cancel y square and y square, we can cancel. Finally, we will have g dash of x is equal to cos x minus x sin x is there, cos x minus x sin x is there. Okay. So, we will have g dash of x is equal to cos x minus x sin x is there. Have to find g of x. So, just write integral of g dash of x dx is equal to integral of, that is cos x minus x sin x, cos x minus x sin x dx. Okay. Therefore, integral of g dash of x is actually g of x, that is equal to integral of cos x dx minus integral of x sin x dx is there. Okay. So, we can write this as integral of cos x dx is equal to integral of cos x is sin x, okay, minus integral of x sin x. So, we can write this as this is equal to, sorry, we can write this as integral of x sin x, x into minus of x into integral of sin x, that is equal to cos x, sorry, minus cos x, okay, minus in the first function into integral of the second, integral of derivative of sin x, sorry, derivative of x first function 1 into integral integral of derivative of sin x into integral of the sin x, that is equal to minus cos x dx. Okay. So, we can write this is equal to sin x, and this minus and minus will be plus x cos x, and finally, we will have here it is equal to, we have 3 minus are here, therefore, minus integral of cos x, sorry, minus integral of cos x dx is here. So, finally, we will have this is equal to sin x plus x cos x plus x, sorry, sin x plus x cos x and minus integral of cos x is minus sin x is there. Therefore, we can cancel this sin x and this sin x. Finally, we will have the value g of x is equal to x cos x, g of x is equal to x cos x. So, finally, we have the value g of x is equal to x cos x plus c 1, or simply we can write this as x cos x plus the constant of integration is c 1 is here. Okay. Fine. So, we can apply into. Therefore, equation 2, see, therefore, equation 2 becomes as u of x y is equal to, we can go back to equation 2, in equation 2, see equation 2 x y square plus g of x is there. So, we can write this is equal to x y square plus g of x is there, instead of g of x we can write x cos x plus c 1. So, this is equal to x cos x plus c 1, okay. Or we can write this is equal to x y square, that is we can write this is equal to x y square plus x cos x is equal to c is the general solution, of given equation 1, is the general solution of the given equation 1. Okay, we can go back to question again. In question we have this is have to find the particular solution. If it satisfies initial condition y is equal to 1 whenever x is equal to pi. So, we can apply here to find particular solution y is equal to 1 when x is equal to pi, have to find the particular solution whenever y is equal to 1 whenever x is equal to pi. So, we just replace the value of x and y in equation this general solution, that I would like to put equation number 3. So, put in 3, see we will have this is equal to value of x is equal to pi and y is equal to 1. Therefore, we will have this is equal to x y square, that is equal to pi into y square is 1 square, and finally, we will have x cos x, that is 1 into pi into cos pi plus pi into cos pi is equal to C. See, here we have this is pi, cos pi is minus 1, minus pi is equal to C, that is the C is equal to 0. So, we found the value of C, C is equal to 0. Hence, the particular solution is, hence the particular solution is, so we can say the particular solution is, we can write this is equal to xy square plus x cos x is equal to 0, xy square plus x cos x, the value of C equal to 0, xy square plus x cos x is equal to 0 is the particular solution. So, this is the general solution of the given differential equation, and from there in a particular case whenever y is equal to 1, when x is equal to pi, thus this is the particular solution of the given differential equation. Okay, fine, we can just move to another question, and this is in all the cases that we done before, it is that we just discussed, it is that we are just started with this one, we will find the dou m by dou y and as well as dou n by dou x. From there we check whether the dou m by dou y is equal to dou n by dou x or not. If they are equal, we can say that the differential equation is exact. If it is exact, we just found the general solution as u. If u can be integral of n of x y dy plus g of x, or otherwise integral of m of x y dx plus g of x g of y. After we will find the value of g of x, and then we replace the value of g of x or g of y, then we can find the general solution. Okay, fine. I would like to say I would like to do one more thing, it is that, see, I would like to start with new question. Before starting the question, I would like to say you can find the general solution of exact, can find general solution of exact differential equation by using the formula integral of m dx plus terms in n plus integral of terms in n not involving x, integral of terms in n not involving x into dy is equal to sum c, the constant of integration. Terms in n not involving x. I am presenting this new formula and would like to do a question, and we can compare, no problem. See, integral of m dx plus terms in n not involving x into dy is equal to c. See, we can start with the first question that we done just before. This is, in this question we can say that the question is solve question number 3, solve the differential equation, 2xy minus 3x square, 2xy minus 3x square dx plus x square minus 2y plus x square minus 2y dy is equal to 0. Okay, this is our equation number 1. From here it is understood, it is that this is m and this is n. Like m is 2xy minus 3x square, n is x square minus 2y is there. Okay, fine. We understood it is that dou m by dou y, that we already done, it is that dou m by dou y, that is with respect to y we can partially differentiate, therefore, this is 2x. The term minus 3x square is the 0. because it is the function, just kind of function, part of the function, just contain only x. Therefore, while partially differentiating with respect to y, that will be constant, that will be 0, and dou n divided by dou x. We can partially differentiate x with respect to x square with respect to x, that is 2x. The term contains only 2y, the term 2 minus 2y contains only y, therefore, that will be 0. Therefore, we can say that dou m divided by dou y is equal to dou n by dou x, hence one is exact, sorry, hence one is exact differential equation. Hence, we can say that the given differential equation, one is exact differential equation. Okay, fine, and we can find by using this formula. Can go back to integral of m dx plus terms in n not involving x dy is equal to c. Sorry. So, therefore, general solution is general solution is integral of m dx plus integral of terms in n not involving x dy is equal to c. Fine, we can come back to again m and n, and now we have m is equal to 2xy minus 3x square. Therefore, this is equal to integral of 2xy minus 3x square dx plus integral of terms in n not involving x, the first term containing this one x square sorry, the first term containing x square. So, which contains the terms of x, therefore, we neglected it, but the second term is minus 2y, which does not contain the any x, therefore, we can consider that. Therefore, minus 2y only is there, therefore, minus 2y dy is equal to c. Okay, fine. See, while integrating with respect to x, we will have this is equal to 2x square y divided by 2 minus 3x cube by 3 minus 2y is there, minus 2 y minus 2 y square divided by 2 is equal to c. Okay, we can cancel this 2 and 2, we can cancel this 3 and 3, we can cancel this 2 and 2, we can cancel. So, finally, we will have say x square y minus x square y minus x cube minus y square is equal to c is the general solution, okay, fine, is the general solution, okay, fine. See, my dear students, just if you think you may think about the question that we done firstly, whose general solution is the same. That is the terms in n not involving x. Okay, see. So, we found this is the u of x square y minus x cube plus g of y. Finally, we found g of y as x square y minus x cube minus y square equal to c is the final solution. So, finally, the same solution, finally, we got the same solution lastly. See, just a minute, okay, fine, this is the solution, x square y minus x cube minus y square is equal to c is the general solution. I would like to move one more question, just we can move to question number 4 of the just we can move to question number 4. See, in question number 4 we discuss solve the differential equation, solve the differential equations 1 plus 4xy plus 2y square dx plus 1 plus 4xy plus 2x square. 1 plus 4xy plus 2x square dy is equal to 0. This is equation number 1. This is equation number 1. 1 plus 4xy plus 2y square dx plus 1 plus 4xy plus 2x square dy equal to 0. So, from here we have m is equal to 1 plus 4xy plus 2y square and n is equal to 1, sorry, here we have 1 plus 4xy is here, 1 plus 4xy, okay, 1 plus 4xy plus 2y square, sorry, 2x square, 2x square is n. Okay, so fine, we can partially differentiate with respect to y. Dou m divided by dou y is equal to 1 plus 1 is 0, 4xy is 4x plus 2y square is 4y is there, and n, that is equal to dou n divided by dou x is equal to 1 is 0, while partially differentiating with respect to x we have 4y and we have 4x is there. So, 4x plus 4y, here we have 4x plus 4y, therefore, dou m divided by dou y is equal to dou n divided by dou x, hence given differential equation 1 is exact. Okay. So, we can solve it. So, while solving this, the solution is, therefore, general solution is integral of m dx, okay, plus integral of terms in n not involving x, not involving x dy is equal to c. Okay, we can come back, and m is 1 plus 4xy plus 2y square. Therefore, we can write integral of 1 plus 4xy plus 2y square, sorry, 1 plus 4xy plus 2y square dx, 1 plus 4xy plus 2y square dx. Okay. And then we again we have the terms in n not involving x, that is here this is the n. Here everywhere it in the second and third term it involves the x. Therefore, we can neglect the second term and third term because that involves x. So, only the term not involving x is the 1 only. Therefore, we can write this as, say, my dear students, plus the terms in n not involving x, that is the 1 only, dy is equal to c. Okay, fine. While integrating with respect to x, integral of 1 dx is x, integral of 4xy dx is, that is the 4x square y divided by 2, integral of 2y square with respect to x is 2y square x, and finally, we have integral of 1 dy, that is y is equal to c is there. See, we can cancel this as, that is we have x plus, we can cancel this 2 and 4, therefore, 2x square y plus 2y square x plus y is equal to c. The constant of integration is there, sorry, the constant of integration is there. This is the general solution of the given differential equation. Fine. So, we can solve like this, and this is the general solution of the given differential equation. So, we discussed in both the last two sessions, we discussed about the exact differential equation. We can find many questions in the literature of the differential equation about the how can we solve exact differential equation. Whenever we can say that a differential equation is exact, how can we find the general solution of the exact differential equation? How can we find the particular solution of a exact differential equation? I would like to give you some assignments, write down some assignments. The first one is solve initial value problem. Solve initial value problem. Y minus 6, sorry, y minus 1 dx, y minus 1 dx plus x minus 3 dy, x minus 3 dy equal to 0 is equal to 0 and y of 0 equal to 2 by 3. Y of 0 sorry y of 0 equal to 2 by 3. Okay, fine. This is a wonderful question of initial value problem and very simple question. You can find this is here we have this is m, y minus 1 is m and x minus 3 is n. Okay, write down the one more question. It is that solve the differential equation, solve the differential equation 1 plus y dy by dx, 1 plus y into dy by dx is equal to 1 minus x, 1 minus x. Okay, fine. This one, this is also you can rearrange the question. 1 minus x dx minus 1 plus y dy is equal to 0. In that case also, that is in the form of m dx plus n dy is equal to 0. From there we can find m and n, and also we can find dou m by dou y and dou n by dou x. If they are equal, dou m by dou y is equal to dou n by dou x, then we can say that the differential equation is exact. If it is exact differential equation, we can solve in either forms that we discussed two types of two methods we showed in the previous sessions to solve the exact differential equation. If it is initial value problem, after finding the general solution, you can just apply the particular values, the particular value of x and y in the general solution. Then there we can find the value of the arbitrary constant c, the particular value of the arbitrary constant c. So, while replacing the value of the arbitrary constant c in the general solution, we will get particular solution for that initial value problem. Okay. This is all about the exact differential equation. You can watch many related the videos of the exact differential equation. You can find many questions about the exact differential equation in the literature. It have very vast applications also. So, you may try to work it out on the exact differential equation. Okay. Thank you for watching this video. Continue your watching. Thank you very much.